Do you also want to spend more time with your colleagues drinking coffee? Then you could start an automated optimization. It will run for some time. Welcome back to our Lifehack series. Today and also in the following weeks we will focus on optimization, and I will start with an introduction to that topic. Why we are doing optimization? Well, there are of course a couple of different reasons. Currently we have the climate change, we need CO2 reductions, we need to reduce the energy consumption and increase sustainability. And for these topics we have also some rules from the European Union, for example, which you can see here. In the end, most of the optimizations are focused on efficiency optimization. And you can do that for existing machines or during the design process of completely new machines. And we optimize with Fine Design 3D and have a standard workflow for turbo machinery, but in the end the underlying optimizer is independent from the application, so we can also adapt it to marine topics or external aerodynamics, and we will show you some examples later. You can do an optimization also in a manual way, let's say, so you can change a few parameters, do your project, simulate that, that's what we call screening, and improve the results step by step. However, that approach is first of all very tedious, and in the beginning you can or you may reach 80% of the result with 20% of the effort, but in order to reach the 100% of the result you need much more effort. And even worse, the last 2% probably takes 98% of the effort. So a manual optimization can't do that, and that's why we go for an automated optimization. So in the beginning we are defining our parameters, we are generating a database, we're defining goals and constraints, and we let the optimizer run and do its job. We can also do parameterization with discrete values. So for example the blade count, if you think of a turbo machine. We can couple CFD with structural mechanics. We can even use external software if you want to. And in our optimization tool we have an advanced post-processing. How that works in detail we will show in the next weeks with small life hacks to each topic. But just to show you the general workflow, in the beginning we parameterize the initial geometry, we generate a database with design of experiments, so we have our design space where a couple of designs are computed, and based on that we have a surrogate model which is very fast in computing and not doing the real CFD simulations. On that model we do an optimization, which is again very fast, and of the best results we do a CFD CSM simulation. And by that we enrich the database, we start that loop again and repeat that under convergence, and finally we get a new design. To show you what is possible and also to get your full attention, I show you some example cases. Here we have a diagonal fan, and the goal was to optimize efficiency for 3 different operating points. The parameters were defined such that the rotor, the starter and also the channel contour could change. And we can nicely see here an improvement of inefficiency of a few %, which also was confirmed by the measurements. Here we have a completely different case, the shape optimization of an electric catamaran with 2 operating points, and the goal was to reduce the resistance. You can see the improvement here compared to the base design, that we have a smaller wave elevation, and as it is an electric ship we have a battery on board. One battery is supposed to run for 5 hours, the second one for 7 hours, and if we run with high speed at 7 knots we get 50 minutes more travel time, or if we reduce the speed and have the bigger battery we can even get more than 110 minutes of extra endurance. Another case is shown here. We have an axial flow fan with a reversible flow, so it should operate in 2 directions. And the main goal here was to reduce the material usage by increasing thrust and maintaining efficiency. The outcome was that with the optimal design we could reduce the maximum stresses and also reduce the material usage by more than 26%. So I hope with the 3 small examples, I could show you how nice it is to have an optimizer running on your specific case. And in the next weeks, we will have short life hacks about the different specific topics: parameterization, database generation, data mining, and so on. We will publish that on LinkedIn, provide a YouTube playlist where you can also see the videos later. Of course, they will be available on our website, and you will find the links in the video description below. Furthermore, in the next week we will have a live webinar where we will show you one optimization case where we are optimizing a radial compressor, including the CFD flow and structural mechanics with the von Mises stresses. So I hope to see you in that webinar next week. And for today, I say thank you very much and see you next time.